Hey, so we're going to continue looking at moles, and this time, instead of looking at moles and representative particles, we are going to look at moles and molar mass. Okay, so I shall share my screen. Oops, wrong button. We're going to title this moles and molar mass. All right. Baby steps. Baby steps. Everything gets real easy. Just follow the baby steps, all right? Moles and molar mass, all right? I don't know why. I'm gonna go like this. Ah, that's better. Days beta. Go like that. All right, so once again, we know that 1 mole, right, is equal to Avogadro's number. And we know that that is equal to 6.02 times 10 to the 23rd particles. We know that the particles that are being discussed is the dependent upon the type of matter that is being discussed. We've got atoms, ions, molecules, and formula units. Today, we are going to talk about moles and molar mass. All right, what is molar mass? It is the mass of 1 mole of a substance. Boom. You've got to have a pure substance to have a mole. Well, to have a molar mass, we would need to have, well, not necessarily. So what you need to know is that 1 mole of an element has a mass in grams that is equal to its atomic, that's right, average atomic mass. And what is that average atomic mass? First of all, it's the average of all the isotopes in their abundance added up, remember, and it is the mass on the periodic table. Okay, so it is really cool that the way this works. All right, so you need to today, if you haven't, the periodic table, get your calculator. Calculators are back, guys. Oh, are they back? Oh, are they ever? Okay, so sorry, I need to clean up my little work area here. Let's look at our periodic table. You need to have it readily available. If you look on the periodic table, we see, look at lithium, atomic number 3. All right, 1 mole of lithium is equal to 6.94 grams. Okay, so if I said, hey, I need you to go get me a mole of lithium, could you count 6.02 times 10 to the 23rd atoms of lithium and go, oh, here you go? No, it would take you your whole lifetime times infinity. But what you could do is go, oh, well, look on here, lithium weighs 6.94. So if I was to get you 6.94 grams of that, Ms. Murphy, that would be equal to a mole, which would also contain 6.02 times 10 to 23rd atoms of lithium. Okay, so the mass is a way of counting. We count by weighing, if you will. Star, 2 numbers after the decimal in all molar masses. At least, okay? At least. Do not round these molar masses. You need to use the periodic table I gave you because some have slight variations. This way we'll all have the same answers. All right, let's do it again. What does 1 mole of carbon weigh? Well, look on your periodic table, find carbon, atomic number 6. What does it weigh? It weighs 12.01, 2 numbers after the decimal, grams. Okay, so that the molar mass, let's look at this, get one more element, copper, is equal to 63.55 grams per mole. Look at the units. Oops, don't erase the units. Look at the units. So the molar mass has units of mass per mole. We just get it from the periodic table. Let's look at the molar mass of compounds. All we do is add up the masses of all elements in the compounds using the periodic table, okay? That's it. I can write messy, can I? All right, that's all I'm going to do. So let's start with H2O. All right, and you see that I have 2 H's. Each has a mass of 1.01 grams. I have 1 oxygen. Each has a mass of 16.00. So 2.02 plus 16.00 gives me a molar mass of 8.02 grams per mole of water. So if I said, hey, I need you to bring me a mole of water. I need a mole of water. You could go out and you could get 18.02 grams and you could deliver it to me. And that would be 1 mole of water. And in that 1 mole of water, right? It's on a scale. It weighs 18.02 grams, right, of water. How many molecules of water would be in here? How many HOHs would be in that sample of water? 6.02 times 10 to the 23rd. H2O molecules in the 18.02 grams of water, because that is the mass of 1 mole, and 1 mole has Avogadro's number of particles. The particles here are molecules because it is covalently bonded. All right? So if I asked you to bring me a mole, you couldn't go count the molecules, but you could go get me a particular mass. So that's what we mean by counting by weighing. It also, what we'll learn, will allow me to take a particular mass of water and figure out, and use that mass to determine how many molecules of water are in it. We count by weighing, and we will call those molar conversions. And that will be our next mini lecture, keeping this baby. Let's look at another one. Let's look at aluminum sulfate. Maybe let's start a little slower. Let's look at sodium sulfate. We need to know the molar mass. All right. Well, we need to break it down. I've got 2 sodiums. Each has a mass of 22.99. Maybe you go, pause and do this. Come back. I've got 1 sulfur. Each has a mass of 32.06. And I've got 4 oxygens. Each has a mass of 16.00. Now, personally, guys, I do not sit here and write all this down. I go 22.99 times 2 equals, plus 32.06 equals, plus parentheses, 16 times 4, close parentheses, equals, and make sure my answer makes sense. That is 142.04 grams per mole. All right, let's do one more. Let's say that we have aluminum carbonate. All right, All right, we need to know the molar mass. So we've got aluminum. There are 2. Each aluminum, what's 26.98. Carbon, I have 3. Each weighs 12.01. Oxygen, I have 9. Each weighs 16. All right, so if I multiply all of those and add them together, 2 times 26.98 plus parentheses 3 times 12.01 close parentheses equals plus parentheses 9 times 16 close parentheses equals 233.99 grams per mole. All right, so 1 mole of aluminum weighs 234 grams, but I still have this many formula units, right? So we see that each formula unit must weigh more, because for this many formula units, it weighs this much. But for sodium sulfate, if I were to have this many formula units, the same amount, and I'll call them formula units because it is ionic, well, that only weighs 142 grams. So each one is lighter, but 1 mole is the same amount, but the mass changes. And notice for water, water's really light. If I need 6.02 times 10 to the 23rd pieces, which would be called molecules because it's covalent, I would only need 18 grams of water. Same number of particles, but a different mass for those particles, okay? So the molar mass has units grams per mole, and it is found on the periodic table. And we will always use 2 numbers after the decimal. And I encourage you to print the periodic table that I posted on your Google Classroom, because there are variations. Some give you 3 to 4 numbers after the decimal, and they round differently, all right? Thank you. Bye.